Welcome to the Explainer. If you're on the web, and I know you are, you're using JavaScript. It's the engine running behind, well, basically everything you click on, everything you watch, and everything you share. But all that amazing power comes with a hidden price tag, built on a foundation that, well, as we're about to see, can sometimes be as fragile as a house of cards.
So just how dominant are we talking? Get this, 99%. Almost every single website out there is using JavaScript on the client side. Let's be clear, it's not a language of the web, it is the language of the web. Full stop.
You see it every single day. Every time you like a post, or watch a video, or drag a map around with your finger, that's JavaScript in action. It's the magic behind all those interactive, dynamic experiences that we pretty much take for granted now. Okay, so here's the big question. What if that very thing that makes it so powerful is also what makes it so dangerous? We're going to get right into it, breaking down why this ecosystem is so risky, and more importantly, what you can actually do about it.
You know, the secret to JavaScript's success is this huge, incredible collection of shared code. We're talking about libraries and packages that let developers build amazing things super fast. But, and it's a big but, when you're relying on code from thousands of different people, you're also opening the door to some pretty serious security headaches.
So every single project you build has what we call a security footprint. And because of how modern web development works, with all its shared code, that footprint is almost always way bigger than you think. It starts with what we call direct dependencies. These are the tools and libraries that you, the developer, actually choose to bring into your project. You add them to your package.json file. But even a simple project can end up with dozens of these pretty quickly.
But here's where it really gets wild. Each one of your direct dependencies, well, it has its own list of dependencies, and those have their own dependencies. We call these indirect dependencies, and it's like a giant web. The cake mix analogy is perfect. You trust the brand on the box, sure, but do you know who supplied the flour or the sugar? A single problem buried deep in that supply chain can completely ruin the whole cake.
And you better believe that attackers are really good at finding the weak links in these complex chains. They tend to use a few common but really effective kinds of attacks. So let's take a look at what those are.
First up is a classic, SQL injection. So picture your database as a librarian who takes every request literally. An attacker can craft a special request that doesn't just ask for a book, but tricks the librarian into handing over the keys to the entire building. They can steal data, change it, or even delete everything.
Then you've got cross-site request forgery, sometimes called session writing. This one is so sneaky. Let's say you're logged into your online bank. An attacker could trick you into clicking a link, maybe in an email, that secretly uses your active login to transfer money without you even realizing it. They're basically hijacking your good name.
And of course, the big one, cross-site scripting, or XSS. This is what happens when a website doesn't properly check the stuff users type in. An attacker can post a comment that contains malicious code. Then, when other people view that comment, that bad code runs right in their browser, stealing things like cookies or passwords. Okay, so that all sounds pretty scary, right? Like you're walking through a digital minefield. But here's the good news. The developer community has come up with a really powerful set of tools and best practices, a modern-day shield to help you defend your code.
Look, there's no single magic solution here. Good security is all about defense in depth, having multiple layers. That means using automated tools called linters to catch common code smells, constantly auditing your dependencies for known issues, and being super careful about any data that comes from the outside world.
One of the absolute golden rules is to never, ever trust user input. And your first line of defense is actually built right into HTML itself. You can use simple attributes on your forms to say, hey, this field is required, or this needs to be a number, stopping bad data before it even gets to your server.
And this is just a perfect example of how the language is actually evolving to help us write safer code. It used to be we'd have to write these ugly, long if statements just to make sure we didn't cause an error trying to access some data. Now we have optional chaining. One clean, simple, and safe line of code. It's fantastic.
So we've talked about the core language, but that's just the tip of the iceberg. A lot of the real power and the real complexity of modern JavaScript is in its frameworks.
Things like React, Angular, and Vue. And they add a whole other dimension to this conversation.
There's a great quote from Ryan Carniato, who created the Solid.js framework. He said, "The quest for simplicity hasn't resulted in making web development simpler." And it's so true. It feels like every time we create a new tool to solve one problem, we just add another layer of complexity somewhere else.
And that complexity is a big reason why something like TypeScript has exploded in popularity. See, plain JavaScript is dynamically typed, which is a fancy way of saying a variable can be a number one second and a piece of text the next. TypeScript adds a safety net and lets you lock in the type, so you catch those kinds of mistakes when you're writing the code, not when your users are trying to use the app.
If there's one thing you can count on in the JavaScript world, it's that nothing stays the same for long. The language and its whole ecosystem are always on the move, always evolving to tackle the next big challenge on the web.
And you can really see how much the pace has picked up. After a bit of a slow period, ever since 2015, the official standard for JavaScript, that's ECMAScript, has been updated every single year. And each update gives us new tools to write better, stronger, and yes, more secure code.
So, looking out at the horizon, these trends aren't just cool new toys. They're direct answers to the problems we've been talking about. WebAssembly lets us run super fast code securely in its own little sandbox. Serverless takes a lot of the infrastructure security worries off our plate. And AI tools are getting incredibly good at helping us find those hidden vulnerabilities before they ever cause a problem.
Which really brings us to the final big question. In this massive, layered, constantly shifting world of code, where does the buck stop for security? Is it the job of the people designing the language, the people building the frameworks, or, at the end of the day, does it all come down to the individual developer and the choices they make one single line of code at a time? That's really the core challenge for everyone building the web of tomorrow.